Imagine if one company stopped shipping its products tomorrow. Not oil, not food, not electricity. One company, one product. And suddenly, Apple couldn't build iPhones. Nvidia couldn't manufacture AI chips. AMD would struggle to release processors. TSMC's factories would slow down. Even companies like Intel, Samsung, and Qualcomm would face massive delays. Sounds impossible? It's not. Because almost every advanced computer chip on Earth depends on machines built by a single Dutch company called ASML. Most people have never heard its name. It doesn't sell smartphones. It doesn't manufacture chips. It doesn't design processors. Yet without ASML, the modern technology industry would come to a standstill. So how did one relatively unknown company become the most important supplier in the semiconductor world? The answer begins with one of the hardest engineering challenges humanity has ever attempted. Back in the 1980s, the semiconductor industry was growing rapidly. Computers were becoming smaller, faster, and more powerful every year. To make that possible, manufacturers needed a way to place billions of microscopic transistors onto silicon wafers with extraordinary precision. The process is called lithography. Think of it like printing. Except instead of printing words onto paper, you're printing electronic circuits so tiny that thousands could fit across the width of a human hair. The smaller those circuits become, the faster and more energy-efficient computer chips can be. Every major chip company depended on better lithography machines. The problem? Building them became unbelievably difficult. That's where ASML entered the story. Founded in the Netherlands in 1984 as a joint venture between Philips and ASM International, the company started as a relatively small equipment manufacturer. Few people expected it to dominate an industry filled with giants. At first, ASML struggled. Competitors from Japan controlled much of the market. Customers weren't convinced. Money was tight. Several times, the company's future looked uncertain. But instead of trying to compete on price, ASML focused on one thing: innovation. It believed the future belonged to whoever could print the smallest transistors with the greatest precision. That decision would eventually change the entire technology industry. For decades, chipmakers continued shrinking transistors. Engineers followed what's known as Moore's Law, the observation that computing power roughly doubled every couple of years. But eventually, physics became the enemy. Traditional lithography machines were reaching their limits. The light they used simply wasn't precise enough anymore. Many experts believed transistor miniaturization was approaching its end. Without smaller chips, progress in computing would slow dramatically. Artificial intelligence, smartphones, cloud computing, advanced graphics. Everything depended on solving this problem. Most companies considered the next solution too difficult, too expensive, too risky. ASML chose the opposite path. It made one of the biggest technological bets in modern industrial history. A new system called extreme ultraviolet lithography, or EUV. At the time, many people thought the project would fail. The technology sounded almost impossible. EUV light couldn't even travel through normal glass. Ordinary mirrors wouldn't work. Even tiny particles of dust could ruin the entire process. Building a machine capable of using EUV required solving engineering problems that had never been solved before. It would take decades of research, billions of dollars in investment, and the collaboration of hundreds of specialized suppliers around the world. Most companies would have abandoned the project. ASML doubled down, because if it succeeded, it wouldn't simply build a better machine. It would build the only machine capable of producing the world's most advanced computer chips. And that would give the company something almost impossible to achieve in modern business: a near monopoly. What made EUV so extraordinary wasn't just the technology. It was the complexity. An advanced EUV machine contains more than 100,000 individual components sourced from hundreds of specialized companies around the world. Some of its mirrors are manufactured with surfaces so smooth that their imperfections are measured in fractions of a nanometer. To put that into perspective, if one of those mirrors were enlarged to the size of Germany, the tallest bump on its surface would be less than a millimeter high. That's the level of precision required. The light source itself is even more astonishing. Instead of using an ordinary laser, ASML fires powerful laser pulses at tiny droplets of molten tin. Each droplet is smaller than the width of a human hair. When struck, it creates plasma reaching temperatures several times hotter than the surface of the sun. That plasma produces the extreme ultraviolet light needed to print microscopic circuits onto silicon wafers. The entire process happens tens of thousands of times every second. And every step has to be nearly perfect. One tiny mistake, one vibration, one microscopic particle of dust could ruin millions of dollars worth of chips. That's why ASML's machines aren't simply delivered like ordinary industrial equipment. They arrive in hundreds of separate crates. Engineers spend weeks, sometimes months, assembling and calibrating them inside highly controlled clean rooms. Each machine costs more than $200 million. Yet companies happily wait years for delivery, because without them, they can't manufacture the world's most advanced chips. This is where ASML's business model becomes incredibly powerful. Unlike companies that compete directly with Apple, Nvidia, Intel, or Samsung, ASML supplies nearly all of them. Its customers compete fiercely against one another, but they all depend on the same supplier. Apple needs advanced chips. Nvidia needs advanced chips for AI. AMD needs advanced chips for gaming. Qualcomm needs advanced chips for smartphones. TSMC manufactures many of those chips. And TSMC relies heavily on ASML's machines. Instead of choosing one winner, ASML sells the tools every winner needs. It's the same strategy that made companies selling picks and shovels successful during the gold rush. The miners competed. The tool suppliers served them all. Of course, this extraordinary position has also made ASML a company of global strategic importance. Governments now recognize that advanced semiconductor manufacturing isn't just about business. It's about national security, artificial intelligence, military technology, economic competitiveness. As a result, exports of ASML's most advanced EUV machines have become subject to strict government regulations. Some countries can buy them, others cannot. That means ASML now sits at the center of one of the world's most important geopolitical industries. It's remarkable for a company that most consumers have never heard of. Naturally, competitors would love to challenge ASML, but that's far easier said than done. Developing an EUV machine isn't like building another smartphone or laptop. It requires decades of accumulated knowledge, thousands of patents, deep relationships with specialized suppliers, and billions of dollars in research and development. Even if a competitor invested unlimited money today, it could still take many years before producing a comparable system. That's one reason ASML's competitive advantage is so difficult to replicate. Its biggest asset isn't just the machines. It's the expertise built over decades. Perhaps the biggest lesson from ASML is that the most powerful companies aren't always the most famous. Consumers know Apple, Microsoft, Google. But behind many of those global brands are businesses quietly supplying the technology that makes everything possible. Without ASML, there are no cutting-edge chips. Without cutting-edge chips, there is no modern AI revolution, no latest generation smartphones, no advanced data centers, no next-generation processors powering tomorrow's technology. So why does ASML control the world's most important machines? Because it spent decades solving engineering problems almost everyone else considered impossible. It didn't build the products consumers use every day. It built the machines that make those products possible. And in today's technology race, controlling the tools that build the future may be even more valuable than building the future itself.